Hey there, Earth Science students. Today we are going to be starting our portion of this unit dedicated to rocks, and we're mostly going to be looking at igneous rocks. So let's start off with a definition of what a rock is. It's a naturally formed solid found on Earth or anywhere else in the universe, right? Pretty broad definition. That's because rocks are pretty broad. Rocks are mixtures of minerals, organic materials, glass, fragments of other rocks. So they don't have to be made of strictly minerals. We were talking about minerals, and they had a lot of things that they needed to be in order to be a mineral. Rocks are a little bit looser, right? The definition is much looser. It can be made of lots of different things. All right, let's start with igneous rocks. So igneous rocks are rocks that form from the cooling and solidifying of molten magma and or lava. So magma, this is molten rock that's beneath the Earth's surface, and lava is molten rock that is above the Earth's surface. You'll often hear these kind of used interchangeably, but they're not. Lava is at above the surface, it's been erupted, and magma is something that's going to be below the surface. It hasn't been. So we have two major types of igneous rocks. We have intrusive rocks, which are rocks that are going to be cooling underground. They're going to be made from magma. They have coarse or large crystals. They cool slowly because they cool underground. And we got some pictures of them right here. You can see they've got these nice large crystals in them. The other type is going to be extrusive igneous rocks. These are volcanic, so that means they have been erupted and they cool down at the surface. They can cool at the surface. So they are fine, which means they have small crystals, or they could be glassy, which means they have no crystals at all. More like glass. They cool quickly. They form above ground, and they may be vesicular or non-vesicular, meaning the rock has gas pockets in it. So here we have some examples of some extrusive igneous rocks, and we got this one right here down here, this pumice, that actually has those gas pockets in it. So as you can see, what type of igneous rock we're dealing with depends on where it was formed. So if it formed underground, it's going to be an intrusive rock. So you can see, think about like intrusive interior. If it formed above the surface or at the surface, it's going to be an extrusive igneous rock. So think about like exterior, extrusive. So this is page 6 of your reference table, and this is going to contain our scheme for igneous rock identification. This is going to be the chart we're going to be using for this part of the unit. So let's start. Let's look at the Earth's surface right here. This is where it's going to be divided. All the rocks that appear below that line are going to form below the surface of the Earth, and all the ones that appear above that line are going to form at or above the surface of the Earth. The yellow rocks are rocks that are vesicular. They have those gas pockets. Notice only extrusive rocks are going to have gas pockets. The extrusive rocks that don't have gas pockets you can see here, are orange as well. They are all in this part where it says extrusive. Intrusive rocks are going to be shown below the Earth's surface. So right here between extrusive and intrusive, they're all going to be shown down there. Those are all of our intrusive rocks. Diabase kind of goes in between the two of them. That's the only one. All right, let's take a look at the arrows real quick. So the top one is showing us our color, and it refers to the overall color of the rock. So the lighter the rock, the further to the left it'll be, and the darker it'll be further on the right. Now this has to do with what minerals we find in the actual rock itself. The ones that are in the middle are going to have a mixture of both light and dark minerals. The next one is density. So the middle arrow refers to the density of the rock. The lower density of the rock is going to be further on the left-hand side of the chart, while on the right-hand side of the chart, we're going to have a higher density minerals that make up the rock. And then finally, we've got the bottom refers to what elements make up the minerals that we find in the rock. So we refer to rocks that have lots of minerals with silicon and aluminum as felsic, and rocks that have a lot of iron and magnesium as mafic. So aluminum is what Al stands for, and Fe and magnesium, those are our two elements that we often see in mafic rocks. Now that affects the color too. That's why all these things kind of coincide with one another, right? A darker rock is going to be higher density and it's going to be rich in iron and magnesium, while a lighter rock is going to be lower in density and be rich in silicon and aluminum. So rocks on the left-hand side of the chart, obsidian, pumice, granite, are light-colored, low-density, and felsic. Whereas rocks on the right-hand side of the chart, gabbro, basalt, dunite, etc., are dark-colored, high-density, and mafic. So they have a lot of iron and magnesium in them. The third part of the chart deals with the minerals that make up the rock. Each mineral has its own symbol on this graph. We can use it to determine what minerals are found inside of the rocks. So, for example, this first column right here, if we go down from rhyolite, it is going to contain, rhyolite, granite, and pegmatite. It's going to contain all of these minerals: potassium, feldspar, quartz, plagioclase, feldspar, biotite, and amphibole. And you notice that most of these minerals are white to pink or some sort of light color. That's why these rocks have a light appearance. If we look in the middle, right, we've got andesite, diorite, vesicular andesite, a little bit of pumice still too. It's going to contain these minerals. One thing you'll notice is quartz and potassium feldspar are no longer present in these rocks. Plagioclase, feldspar, biotite, and amphibole still are, and maybe even a little bit of pyroxene. You can see the symbol kind of edges in over here. So you can see if I draw a line through andesite and diorite, one might have quartz and one might have pyroxene, but all of them are going to have plagioclase, feldspar, biotite, and amphibole. Our next column, gabbro, diabase, basalt, and scoria, vesicular basalt as well, is going to contain the minerals plagioclase, feldspar, biotite, pyroxene, olivine now, and amphibole. Eventually, we get to peridotite, which only contains the minerals pyroxene and olivine, and dunite, which is just pure olivine. That's it. 100% of the rock, it's just olivine. So you can see how we can read what minerals are found in the rock based on this chart. All right, so you see we've got some map symbols over here. This is what we often see for our different igneous rocks. But that's it. This chart we're going to be using a whole lot during this unit, so get yourself familiar with it, and we're going to be moving on to our sedimentary rocks next.